Welcome to qnawire.
For this question, we are looking at a double slit experiment. So writing down the double slit equation, we have d sine theta equals to n lambda. Alright, but d is the slit separation, theta is the angle that the fringes make with respect to the central maximum, n is the order that we're looking at, or the order of the bright or dark fringe, and lambda is of course the wavelength. So in this case, we're looking at a bright fringe, which means that our n is an integer value, and we're looking at the second order bright fringe. Now we are given that the slit separation is 40 micrometers. The angle in which we observe this bright fringe is at 0.03 radians. So you have to take note that this is in terms of radians, not degrees. So when you put it into your calculator, you have to convert your calculator mode into radians, right, just in case. And we are looking at the second order, so n equals to 2, and we don't know what is the wavelength. So we have to basically identify the wavelength from here, which would give us about 600 nanometers. So from this 600 nanometers, we can equate this to the wavelength of the electron, right? We want an electron to give us the same pattern, right, diffraction pattern, and the only way that you can do that is if its wavelength is the same as that of the light, right? So this will be the same wavelength of the electron. Well, to find now what is the kinetic energy required, we can equate the wavelength to the momentum of the electron to find what is the momentum required. With this momentum required, we can then find the kinetic energy, because kinetic energy is just p squared over 2m. So this is just h over lambda square divided by 2m. So substituting in the values, we square the entire thing. Remember that this is a divide. When you divide times constant with the wavelength, then we square the entire thing, and we divide by 2 times the mass of the electron. This should give us about 6.7 times 10 to the power minus 25 joules. Now we want it in terms of electron volts, right? So to convert that, we have to divide. We divide this by 1.6 times 10 to the power minus 19 joules per eV to give us in terms of electron volts. And we should get about 4.19 times 10 to the power minus 6 eV, or just micro eV.